So today we will show you how to reduce or minimize your egress charges. This is especially required when you have large amounts of data transfer required, maybe hundreds of terabytes or petabytes of data. And in that case, you want to minimize the egress charges, not worrying too much about the latency. So in this case, let's look at how can we minimize egress charges with Arc Orchestrator and Arc Edge virtual routers that we have deployed. Let's log in into Arc Orchestrator. Uh, this is the Arc Orchestrator dashboard where we are logging in into a tenant. It's a multi-tenant platform. So we have already onboarded a tenant called Coke here. And this is the dashboard where you can look at all the deployments that we have done, look at cloud health, deployment of all the arcages that have been deployed in various clouds. It supports role-based access control. So you can also, now we're looking at this screen where we can see there are 3 arcages. One is deployed in GCP and 2 arcages are deployed in Azure. Let's go and see what can we do with ECC. So what we are going to do is we have a customer who wants to transfer a large file from US West to US East in Azure. And he's going to transfer this file over Azure Backbone. So when he uses Azure Backbone, he's going to incur some charges. For the demo purposes, we are taking a file of say 1 gigabytes. We will see what is the charges incurred for that 1 gigabyte. And then we'll see what are the alternate ways in which we can reduce our egress charges. So if you see on this slide, this is the cloud consumption. For now, you can see there is 0 cost in the last 1 hour. There is almost no usage of the cloud account. But now, when we start file transfer, this usage will start going up, as well as the total cost that we are incurring will also start going up. As you can see, we have started the file transfer in the backend, and my cloud usage costs will start going up. Already, I can see that the graph for the cost rate is already going up. So this will refresh in a few seconds, and then we'll see that the cloud costs as well as the cloud usage, egress charges that are being incurred, both will start going up. Let me move it. Okay, so we can see almost 700 megs have gone through. Okay, so now I'll pause it here. So now as we can see that I have sent a file transfer and that file transfer is complete. And now I have incurred some charges on this part of the screen here. So you can see what this customer now wants to do is he wants to see, is there an alternate way through which I will not incur charges or I can minimize the egress charges? So he is turning on ECC on this Azure West US Arcade. And now let's see if BGP, till now it was using BGP to go through Azure West, go from Azure West to Azure East using the cloud backbone, the Azure backbone, that because BGP has selected the shortest path first, that was the closest path. Now we'll see what ECC decides to do. So we can move it forward and see what is happening. So my file transfer, the previous file transfer is complete, and this is the flow, the current throughput. So the throughput is 0 now, and we have to start the same file transfer again. So we'll see what happens now. So the second file transfer has started in the background, and we see that the cloud usage cost and the usage rate has started going up. So we are transferring the same file again, and we see that there is 2 lines now. One is for Azure and one is for GCP, as you can see. So what has BGP done in the background is BGP has started considering the cloud costs. So it has started taking egress cost into making a routing decision. So instead of going through the Azure backbone, it has started going from US Azure West to GCP West, and then from GCP West to Azure East via internet. Because we know that cloud providers provide 100 gig to 200 gig of free internet tier at the first tier, and that's free. So it's trying to use the internet first tier as a transport in order to minimize your egress charges. We can see when we are flipping between the 2 bars here, the usage is increasing. The cloud egress path is being used, but the cloud costs for the second file transfer are not increasing. So what essentially is happening now is BGP has figured out that if I go through the internet in my current tier, I can minimize the egress charges because I'm taking egress charges into my routing calculation. So the routing calculation is the criteria to make the routing decision. Hence, we can see that by adding an extra hop in GCP, we are able to go from one cloud provider to the other region with an extra hop, but minimizing the charges. So you can see the cloud usage cost is increasing, but the cost is not increasing for the second transfer. That is a flat bar. So almost 2.6 gigabytes has been transferred. We will be going to almost 3.2 gigabytes. So see, the cost has not increased for the second transaction here. This usage increases, but the cost is not increasing. So essentially what we have done is, by activating ECC, we are forcing the routing protocols to consider all the underlay available paths available and make a routing decision that minimizes the egress charges. So although these costs are very minimal here, but if you think about it and multiply by, let's say we are going to do transfer of 100 terabytes or 1 terabyte or 1 petabyte, then you can easily multiply these costs by 10 to power 6 or 10 to power 9. And then that will be the magnitude of savings that you will be realizing when you have multiple paths available across multiple clouds and multiple workloads in a complex customer environment. Any questions?
How does this get seeded? So I'm curious, right? I understand it's based off of the type of contracts you have, volume of you've already sent.
Yeah.
How does your environment know that information? Like, what do I have to put in if I'm the operator of this network so that it can start making these decisions with some logic?
Yeah. Great question. So a few things. One is we dynamically poll the publicly available information. So when it comes to inter-region transfers, for example, that is publicly available.
And that's a set fixed cost. It costs X per gig.
Whatever it does, and it's typically by time of day that might change. The internet costs are also going over the internet. That is also publicly available information. We're constantly polling this at different intervals.
Mm-hmm.
So that's one aspect where we're using APIs. The second aspect is if you have any direct links that you've negotiated, let's say you're working with Equinix or Megaport or CoreSite for that matter, and they've given you a leased line or a dedicated link, you've negotiated some prices for that, you can upload all of that information into our Arc orchestrator. That's the system. So it'll take that into account as well.
And you're going to associate that link with like the port that it terminates on or something like that?
Exactly.
Okay.
So we've got the Arc edges, which are really our virtual routers or the virtual instance of our operating system installed on each one of these VRFs, right? And in once they're there, they're constantly polling and pulling the information and feeding them that back so that at an Uber level, you can the routing protocol can then decide which is the best path to take in order to reduce the costs.
Now, within the cloud, are you building like overlays between those edges so that if I want to send traffic, over an inter-region link and then out another link that exists over here, I'm in some sort of tunnel between them to make sure that it goes over there, and then you're
absolutely.
I heard BGP. You're manipulating BGP metrics to make that happen.
Yeah, if you wanted to take that, Ashish.
Yeah, so we are basically creating overlay paths, and then at each of the interfaces, we know what is the egress cost, whether it is going over internet or whether it is going towards a colo or it's going towards the cloud backbone. So based on that, we know what is the cost of that interface. We feed that into the routing table, and the routing protocols make decision based on how can I minimize the egress cost, the total egress cost between a source and a destination. How can I take that all the egress charges and minimize those egress charges?
All right, that makes sense.
And all the arcages that are deployed in various cloud accounts, they are sending their current telemetry information, all the amount of data egress that they have done through that interface. So based on that, how much data you have already sent in this month, we'll know what is the egress charges that you have accumulated so far. So we can automatically, dynamically change the routing to now, instead of going towards cloud, go towards cloud backbone or the cloud backbone. Or if that is there is a cheaper path available through the colo, go through that colo path. So that is how we make the routing protocol wallet friendly, and instead of shortest path first.
Yes.
This is Micheline Murphy. I have a question about the egress cost control and how tunable it is. Say I've got a really cheap link, but it's my backup link and it's 1 gig, and I don't want traffic going over it unless it's an absolute emergency because it's the link of last resort. Do I have the ability as an engineer to say everything but this one, exclude it out, or if it has this, some kind of
absolutely.
to
Yeah, absolutely. So a few things. One is we've got the ability for you to turn on or off ECC on every instance of Arc-Edge that you have. And so now
Every interface, every interface.
Oh,
every
interface, gotcha.
every interface that you have.
Yes.
Okay.
Sorry, go ahead, Ashish.
So think about it, like you have Zoom traffic going on VRF Blue. So VRF Blue is tied to to the Blue interface, and you have a database backup going through VRF Green. So you can turn on ECC on the green interface, or the VRF that is tied to the green interface, because you don't care really how long 20, 12 minutes or 13 minutes it takes for the database transfer. But Zoom traffic, you want to be real time, you want to have good audio video. In that case, you don't want to turn on ECC on that interface, the red interface.
I will add to that and say this is the power of BGP. You can actually color the routes with the communities and other metrics and deep-ref them very quickly. So you have flexibility, and one of the reasons to do that with BGP is exactly that, yeah?
All right, thank you so much. So just to wrap it all up, the key takeaways are we are addressing the world of distributed AI with our next generation networking solution that takes into account data center networking for training, edge compute networking for inferencing models, and then seamlessly tying all this together with our multi-cloud capability. This is sort of a fabric approach that we have. Within the data center, we have IP clause and distributed routing fabrics available for customers to choose depending on what their requirements are. We have a broad range of support of platforms, including smart NICs and DPUs for these edge use cases. With egress cost control, we're able to help minimize the cost that from a cloud traversing perspective. We've got open APIs that help you with very quickly onboarding and automating your entire network. And we have the broadest range of hardware options available to customers.